A particle is acted upon by two forces as shown. We want to find the resultant force acting on the particle. We can draw a vector diagram. The 6 Newton force acts horizontally and the 8 Newton force in this direction. We have the 6 Newton force, the 8 Newton force, and note how it's drawn in the usual way, with the tail of the 8 Newton force on the tip of the 6 Newton force. From our original diagram, we can see that this angle is 60 degrees. To complete the diagram, we need to draw the third side of the triangle. Note the direction that this goes in. We'll call this R, and this is the resultant force. The resultant force is a force that could replace the original two forces and have exactly the same effect. We need to work out the length. This angle we know is 120 degrees, since there's 180 degrees in a straight line. And to describe the direction of our resultant force R, we'll need to calculate the angle theta to the horizontal. To work out the length of R, we can use the cosine rule. A squared is b squared plus c squared minus 2bc cos A. If you're not confident in the use of this rule, you should review the section on the cosine rule. R squared will be equal to 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of 120 degrees. This calculates to 148. R will then be the square root of 148, which is 12.2 newtons, correct to 3 significant figures. To work out theta, we can now use the sine rule. Again, if you're not familiar with the sine rule or confident with the sine rule, then you should review the section on the sine rule. Here we want to find this angle, so sine theta, divided by the side opposite it, the 8, will be equal to the sine of this angle, which we know, divided by the side opposite it, which we know is root 148. And note how I'm using root 148 and not 12.2, since 12.2 is just to 3 significant figures, and the square root of 148 is an exact value. Rearranging, we get sine theta is 8 times the sine of 120 divided by the square root of 148. This is 0.569 and so on, and to find the angle we do inverse sine of this number, and that gives us 34.7 degrees to 3 significant figures. So our resultant force is a force of 12.2 newtons at 34.7 degrees below the horizontal, as shown in our diagram.